So, hello, my dear students and my honorable teachers. So, I am basically from Annasam Dangi College of Engineering and Technology, Asta. I am here to represent my topic, that is Bayes theorem, information and mutual information from the subject of discrete mathematics. Myself, Prasad Mulidhar Savanke. I am from B division of SOI BTech. My URN number is 210311103. My roll number is 2108. I have the guidance of ABC Kalgar ma'am. I am from Computer Science and Engineering department. Now we will start with our most important topic, that is Bayes theorem. Now we will see the introduction of Bayes theorem. Bayes theorem is also known as Bayes rule and Bayes law or Bayes line reasoning, which determine the probability of an event with uncertain knowledge. In probability theory, it relates the conditional probability marginal probabilities of two random events. Bayes' theorem was named after the British mathematician Thomas Bayes. The Bayesian inference is an application of Bayes' theorem, which is fundamental of Bayesian statistics. Now, what is basically a Bayes theorem? Bayes theorem is a method of calculating conditional probability. The traditional method of calculating conditional probability, that is, the probability of that one event occurs given the occurrence of a different event, is to use the conditional probability formula calculating the joint probability of event 1 and event 2 occurring at the same time and the dividing it by the probability of event 2 occurring. However, conditional probability can calculate in a slightly different faster ways using Bayes theorem. So we will show the step-by-step process. When calculating conditional probability with Bayes theorem, you use the following steps. First is determine the probability of condition B being true, assuming that condition A is true. Second is determine the probability of event A being true. Third is multiply the two probabilities together. Fourth is divide the probability of event B occurring. Then this means that the formula of Bayes theorem could be expressed like this. That is probability of A by B is equal to probability of B by A into probability of A whole divided by probability of B. Then the calculating the conditional probability like this. This is especially useful when the reverse conditional probability can be easily calculated or when calculating the joint probability would be too challenging. Now we will see the different formulas to implement in Bayes theorem. Bayes theorem can be derived using product rule and conditional probability of event A with known event B. As from product rule, we can write probability of A and B is equal to probability of A by B into probability B of B, or similarly the probability of event B with known event A, we can write it down as probability of A and B is equal to probability of B by A into probability of A. By equating right hand side of both the equations, we will get the following formula, that is probability of A by B is equal to probability of B by A into probability of A whole divided by probability of B. The above equation is called as Bayes rule or Bayes theorem. This equation is basic of most modern AI, that is artificial intelligence systems for probabilistic inference. Now we will see the example based on the Bayes theorem. The question is, from a standard deck of playing cards, a single card is drawn. The probability that the card is king is 4 by 52. Then calculate posterior probability, that is probability of king face, which means drawn face card is a king card. So we can write the solution by using Bayes theorem as follows, that probability of king by face, that is king face, is equal to probability of face by king into probability of king whole divided by probability of face. We can get a equation as this. So after that we can find out the probability of king, as probability that the card is king is obviously that 4 by 52. We can short it down is as 1 by 13. So we can find the probability of face. That is probability that a card is a face card. That is equal to 3 by 13. Then the probability of face king. So we can find out probability of face king as probability of face card when we assume it is a king. So that is the only one possibility. That is answer is 1. So putting all values in equation 1 as we equated above in the solution. That is probability of king face is equal to probability of face by king into probability of king divided by probability of face. We can uh, equate these values as we have equated that 1 into 1 divided by 13 whole divided by 3 divided by 13. So we can equate this and we will get the result as 1 by 3. That is it, the probability of king face. So the 1 by 3, it is the probability that a face card is a king card. So at last, we will see the applications of Bayes theorem. Bayes theorem is used to calculate next step of the robot when the already executed step is given. Then the Bayes theorem is helpful in weather forecasting in a very deep manner. And the last is the Bayes theorem can solve the Monty Hall problem. Now we will see the mutual information. What is mutual information? It has shortlisted as following 4 points. That is, first is it is a measure for two or more random variables, and it is an entropy based measure basically. Then it is a measure in non-parametric, that is non-parametric measure. Third point. And the last point is it shows, that is mutual information shows the good estimation for discrete random values. So thank you for watching my PPT presentation video on the topic of Bayes theorem and mutual information. So you have any doubts, you can ask me personally. My name is Professor Saunke. I am from B division from SY BTech Anasai Dange College of Engineering and ASTA. So my email address is for yourself is prasadsaunke418@gmail.com. Thanks.